Hi guys, my name is Daniel, and I'm still trying to understand how SQL works under the hood. Therefore, I write my own little database program in Java. Like I always do, I have my little git diff, and there I can see what I actually changed during the last week. And as you can see, it's quite a lot. Let's go through the whole list file by file, and then we will find out where we stand. So first of all, I changed the version to version 1.4. Why did I do so? Before it was 003. The last number is always the video number, like this is the fourth video, and that's actually the version number. So I am now having the version 1 because we actually have a base table, and it's the fourth video. So that's what I did to the version number. Furthermore, I added a new data type, which is called bool. For some reason, I did not add bool to those data type wrappers before. So I did it, and I copied the Java doc, and I forgot to change it. So now it's changed. The data type bool implements iDataType. It's actually complete. It's the same thing than we did before with all the other data types. We have the value, we set the value, we can get the value, we can make it to string. Here we have a ternary operator. If the value is true, it returns true, otherwise it returns false. And the data type is bool, so no magic there. And let's go to another data type I added, text. Text is also of type iDataType, and it's a string. It's just like a regular string. However, I specified it to be in the char set of UTF-8. Our varchars are in ASCII, but the text is actually in UTF-8. I think UTF-8 is a nice little compromise between the UTF-16 or UTF-32, where you have emojicons and all this kind of icons there. We don't need that in the text in a database. So UTF-8 actually just holds all character of all languages, more or less, and is therefore fine. Again, get value, it returns the value. To string, it returns the value, and the get data type is text. So what else did I do? I implemented the deletion of a row. We need to delete a row from the data structure of a B+ tree. Therefore, we go to the BP tree, of course, and we modify the method. We already had all this. Find leaf finds the leaf. Let's have a look at it. Find leaf is actually wonderful, nice little method. I think we used it before. I just renamed it. It's just 2 while nodes, and here it finds the index of the child of a node, and if the node is not a leaf, it continues to go down there until it is a leaf, and then we get the node with the right index. We save there in this while loop and return the leaf node. So let's go back to delete. Here we are. The index is a binary search of the keys in a leaf and the ID. If the index is smaller than 0, which is it can't be, so it just returns. Otherwise, we remove like the element at the index for the keys and remove the row at the index. And then there is like all the other stuff which has nothing to do with actually deleting a row in this data structure. So it was actually quite easy. I thought it would be much, much harder. Therefore, I added some tests. And I created something what I call a base test. It has no actually tests at all. Does it? No. It just imports a file, which is this one here. I downloaded CVS file with like 48,000 cities. Here's the short version, just 1,000, because I had a little problem importing it. I found out that it's not just comma separated, but there is also commas in some of the values there. Let's get back to the file. Let's see if there's London somewhere. There you can see it actually. Here we have London. It's London, comma, city of. And if it's comma separated, it's a hassle. So what I should have done, that's the way to say it, is separate by those 3 characters and not by comma. But I found that out, too late. I thought of it too late. So I kind of did some not so great stuff. So, well, let's say I need to refactor it. For now, it's okay. So we read in the file, we create a file object with the path. I just downloaded those simple maps. So I need to do a shout out. It's from simplemaps.com, data world cities. You can actually download it there for yourself and then place it wherever you want to do. I just limited it to around 1,000 entries. I just wanted to know if it's working or not. Then I'm really created a buffered reader from an input stream, really like the basic stuff. I had a counter because if you look at the file, oh, I closed it, didn't I? Did I? Really? Shit. Here it is. The first line is actually the headers of the table. So I ignore the first line. That's why I do have a counter here. And then I read the line until there's nothing more to read. And for some reason, there is like Korea North, Korea South, and city of like London and so on. These were those things I found, or these words I found when there is an additional comma. So I ignored those lines. Like I ignored the first line, and I ignored the line where there is one of those words present. Then I split the line at a comma. That's actually the problem. We need to fix that, but we do it later on. And I get an array of strings with, I think it's 10 elements. Then I iterate through those elements of this one line. That's like a database cell, actually. And I'm just interested like in the second, the third, the fourth, the fifth, and the 10th column. Here for those I replace the quotes with an empty character and remove all empty characters afterwards. And then we have some cities. City is a list of cities. City is, I define it here. City is a record. If you don't know records, it's like a class, an immutable class, and you have to place all the elements in the constructor. So a city has a name, a latitude, longitude, a country, and the population. So we add new cities for each line, and there we take, that's the name, that's longitude, latitude, that's why they have floats, then the country, and the population, which is an integer on the 10th position. We close the input stream and we create actually a new table. You can see there we have a static table, and here we create it. First of all, I define the data types of the rows, which is like the first one is an integer for the ID. The second one is the name of the city. The third one is the latitude, longitude. That's the country name. And here we have the population. Then we create the different column names. The first one is ID, second name, latitude, what I just said. And then we create a new table. This table is called cities, and it has this type of definition, and those column names are column identifiers. Since I want the ID to start at 1 and not at 0, I defined this counter here, started with 1 and not 0. Then we have the for loop, which actually goes through all the cities, and I create a new row. Each row is of type idata type, and then we have like the ID counter, that's the ID, the city name, latitude, longitude, and so on. And then we use the insert method of the table object to add this row. And we run this before the tests. And then we have another test, it's called the table test, and it extends the base test. So every time I run this test, all those cities are inserted into a table. In the first test, we just check if the creation of a table is correct, and we create a new table. We do not use the table from base test. And we assert that table is not null, that the table name, row columns, column types, and so on. Then we check if that we have as many column identifiers as column definitions, and here it doesn't match, so it throws an illegal argument exception. And here we have the find first leaf test, which actually uses the base test. The first leaf, we have the table find first leaf. I think that's new as well. The find first leaf, it's actually just going through the whole tree structure and always gets the child that is the leftist. And we do this until it's the leaf and we get the leaf node. That's where the first element or the element with the smallest ID will be found. Well, let's get back and let's see. The first element should be the one with the ID 1, and here we have actually the assert, and here it's just a little printout. So let's run the whole thing. And it's true. The first element is the city of Tokyo. Here you can see it's Tokyo. Latitude, longitude, it's in Japan, and it has 37 million people, almost 38 million people. And then we have the next leaf. As you remember, each leaf has a marker or a pointer to the next leaf, so that we can run through all the leaves sequent in order. That's much easier to say. So we want to find the first leaf, and then we take the first line and get next. And since the ID and the first two elements are in the first leaf, the first element in the second leaf should have the ID 3. Let's check that one out. Here we go. It's number 3. It's Delhi in India with 32 million inhabitants. Let's check here. Yes, here we have Delhi. Wonderful. So it works pretty much as expected. I renamed the table to table tree because there will be additional trees in this table class. That's it for this week. I was very surprised that it was that easy to delete a row from a B+ tree. Have a nice week. See you next Sunday.